Alrighty, let's take a look at this question. So given angle P is 33 degrees, side P 7.5, side Q 6.5, how many triangles are possible? Okay, so when you hear how many triangles are possible, you should be thinking ambiguous case of the sine law. Now, when I do these ones, I always draw the triangle like this. I draw my angle that I know in this corner here. So that would be our 33 degrees or vertex P. And then I put the side across from it. Obviously, we're given that as 7.5 centimeters. And then the remaining side that you're given, I always put that up here, 6.5 centimeters. Now, the reason why there could be more than one possible triangle here is imagine if I had drawn this more like this with that 7.5 centimeter side here. There's no reason why we couldn't, because I didn't know this angle at the top and I didn't know this angle on the right, nor did I know the length of this side along the bottom. So no reason why I couldn't have drawn it like that. Now mathematically, what we're going to do is we're going to see if that indeed is a possibility, if there are two triangles, or maybe there's just one triangle, or maybe actually this isn't a triangle because we can't actually close the sides off. So I'm going to show you how we go through that. So first thing I do is I figure out the height of this triangle, which I'll call H. And to do that, we're going to use that right angle triangle here. So we want to know H, which is across from the angle, so opposite. And we have the hypotenuse of that right angle triangle is 6.5. So that means we're going to be using sine theta in the good old SOHCAHTOA thing. Okay, so sine of 33 degrees equals opposite, which is H, over the hypotenuse of that triangle, which is 6.5. Throw that in the calculator, make sure you're in degree mode. We would multiply both sides by 6.5 to isolate H, and we would get H approximately 3.5. Now, what that means, so if H is 3.5, that means we definitely have a triangle. So no triangle, we can rule that one out. The reason why is this 7.5 centimeters across from there. So if for some reason H was bigger than 7.5, that would mean that even if I drew the 7.5 side right here, it wouldn't actually complete a triangle if H was bigger than that. But not the case for us. So as long as our side P is bigger than H, we will have a triangle. Now, if we could have two triangles if we swing this side over here and create another triangle like that. However, if you look at the length of that side, 7.5, it would have to be less than 6.5 because it actually looks more like this, where this is really long like that. So if you swing this over, it's never going to reach because it's longer than this side Q. So what that means is we will not have two triangles because whenever this side across from our angle is bigger than the other side, we won't have two triangles. So in order to have two triangles, P has to be basically in between H, the height, and the Q, the other side. So that's how you get two triangles. One triangle would be when P is bigger than H, but also bigger than Q. So that would be one triangle. And zero triangles would be if H is bigger than P. That would be 0. And, well, there's no such thing as infinite triangles. That was just a spacer to fill, so that one's ridiculous. Okay, so we found out since our side across from our angle is bigger than the other side, we would only have one triangle for that one. Alrighty, I hope that helped.